Okay, over here to the right, we have a picture of the answer that I came up with, where I just let 12 represent an arbitrary constant. The question, and I got that answer by integrating this function right here. In other words, I took the antiderivative of this, plus the antiderivative of this, and I actually put a -3 out front and took the antiderivative of that. Right, this is a dx. And I'll leave that to you. The question is, how do we convert this x squared minus 3x minus 7 over these factors to equivalent expressions involving a, b, and c? And when you're converting a rational function like this to partial fractions, there's a theorem that says that you can decompose this into, or expand this into a over 2x plus 3. And then if there's an exponent of 2 here, you have to use b over x plus 1 to the first plus c over x plus 1 quantity to the second power. If this had been a third or cubed, we'd have to have plus d over x plus 1 the quantity cubed. And so when we've got this expression, or this equation, I should say, what we do is multiply through by the LCD of all these denominators. So this will become x squared minus 3x minus 7 on the left. When I take that LCD times this first term, the 2x plus 3's cancel out, and I get x plus 1 the quantity squared. And by the way, the LCD is 2x plus 3 times x plus 1 the quantity squared, not cubed. Because all of those denominators divide into that expression evenly. I'll get b over 2x plus b times, rather, 2x plus 3 times one of the x plus 1's cancel out, but I'll still have another 2x plus 1, plus c times the quantity 2x plus 3. Now, one way to solve for a, b, and c at this point is to multiply all this stuff together, collect the x squared terms, and you can equate coefficients. Sometimes this technique works a little more easily. If you let x equal -1, you can see that these terms here with x plus 1 in them are going to disappear, and we can find c. So if I put -1 in for x, I get c equals -3. And likewise, if I put -3/2 in for x, the b term and the c term are going to disappear because they'll become 0. So I get -3/2 in for x, 9/4 plus 9/2 minus 7 equals a to the -1/2 squared. If you convert all these to have a denominator of 4, this is what you get, and multiply everything through by 4. 9 plus 18, 27 minus 28 is -1. So that we have a is -1. Now, the problem is, how do we find out what b is? Well, we already know what a and c are. So here I've rewritten that original equation with a replaced with a -1, c replaced with a -3. And now I've got, if I let x equal 0, I can find b. I could let x equal anything I wanted except for -1 or -3/2, but 0 is the easiest. So on the left, I get -7. Do the substitution, I get 3b equals, this is a 9 right here. 3b equals 3, so b equals 1. Okay, and now I can rewrite the original integral as this set of partial fractions added together. A is replaced with -1, b is replaced with a 1, c is replaced with a -3. So if I want to find the antiderivative of that, I can take the antiderivative of each term, which if this exponent is 1 with no exponent here, you have to use U substitution if you want, and the antiderivative is natural log. Here we let u equal x plus 1 perhaps, and you get negative 3 times dw over u squared, or w squared rather, which is u to the w to the minus 2, and that's what you get for the antiderivative. Okay, and if you go to Desmos, when I give you this graph, that's your answer. If you use the Desmos derivative operator and the original function, these two should overlap each other, and you'll see that they do. There you go. Hope that helped. If you have any questions, post a comment.